Next up is chord properties. What are chords and what do they have to do with circles in this unit of circle geometry? But before we get to that, I just want to go over some terms that have to do with circles that we keep mentioning over and over and over again. I just want to get it all out now. So let's just start with, first off, what is a chord? And a chord, you could read the fancy definitions up here, but I prefer looking at it just on an actual circle. So the visual look helps me more than just the definition in words. So anyways, there's a chord right there. Like it says, a line with two endpoints at the end of a circle. So a chord. Remember, the tangent was a line that is on the outside of the circle and just sort of touches once on the outside of the circle. So a chord does what that does. A secant is a line that crosses two different points in a circle. It's kind of like a random line that just goes slicing through the circle like that. So that's a secant. A diameter, which you should know, is a chord that happens to go through the center of the circle, and it gives you the distance across the center of the circle. That's what diameter is. The radius, as you should know, is half the diameter, or it runs from the center of the circle to the outside of the circle. So it gives you half the distance across a circle. A segment is an area, so it's not just a line, it's an area of space which is separated by a chord. So for example, all this space there would be a segment. Kind of looks like a watermelon. Or another segment would be the other half, right there. Those are segments. And then there's a sector, which is just an area in a circle that's separated by two radiuses, or radii. So if I draw a radius there and a radius there, that little space in between could be a sector. And it kind of looks like a pizza, like that. That's a sector. Then there's things called arcs. And an arc is just a section or a part of the entire circumference of the circle. Circumference, remember, is the distance around the circle. So a part of it, any part of it, would be an arc. There are major arcs, one that covers more than half the circle. So like if I went from here to there, it covers more than half the circle. That would be a major arc. Then a minor arc covers less than 50% of the circle, like say from here to there. Alright, so just some words that you may come across. Minor arc, yeah, again it would be a minor arc, right there, that green. And the major arc would be the blue. More than half the circle covered by it. Okay, so when you name chords, again, you use the letters, the endpoint. So these are all chords, TA, TN, NA, or again, you can flip the letters around. So there's that one there, TN, the blue TA, and the black AN are all chords. And they still have the little line thing on top to show that they are just line segments that happen to also be chords in the circle. So when you're inside a circle and you're naming an angle, the letter where the angle is will be in the middle. The other two letters will be the other endpoints of a line. So for example, the angle ATN, the middle letter tells us the actual angle point. The angle is in letter T, so you go ATN. You could say NTA, that'll work as well. You can switch these two outside letters around, but the middle letter tells you where the angle is. And there, if you have an angle at that point, what the N is, you could call it TNA, or you could call it ANT. They happen to call it ANT. And then if there was an angle there, up by the A, you could call it NAT. Anyways, like I say, fast forward to that one. there's three main rules with chords, and if any two is true, then the third one must also be true. Here's the first rule. If a line through the center of the circle is perpendicular to the chord, then it must bisect the chord, which means cut it in half, exactly in half. Here's what I mean. So, if a line through the center, how do you know through the center? Because it goes through that center dot. If a line goes through the center and it's perpendicular to the chord, there's the chord right there. Perpendicular means it's at 90 degrees. That means that that line is cutting the chord directly in half. So this is half of that. All right. So like it says, the two sides of the chord have an equal length. So for example, here again is a line going through the center of the circle. There's a chord. It's perpendicular, shown by the right angled triangle boxy things. So if AB is 10 centimeters, how long must AC end up being? Well, if that is being cut exactly in half by this line, and that's 10, then the whole distance must be 20, because that's 10 and that's 10, so AC must be 20, because AB is 10 there. BC must also be 10, and then the entire distance, AC, the full distance across, must be 20, 20, 20. There you go. All right, here's another one. It's the exact opposite. So if there's a line that goes through the center and it bisects the chord, that means that line must be perpendicular. It's the exact same thing as the other one. So if there's a line and it goes through the center and it slices the chord, well, then it must be perpendicular. Sorry, if that line goes to the center and it bisects, then it must be perpendicular. Remember, bisect means slices exactly in half, two equal parts. So the black line crosses the chord at 90 degrees. So it's perpendicular. Okay, so let's take a look at this one right here. So find the value of x in this diagram. So to do this, you first have to realize that here is a line going through the center of the circle. It doesn't have to go through the full distance. It does go through the center. There's the chord right there. So it does bisect. And other than knowing that it bisects, we also know that these two angles here are perpendicular or 90 degrees to that line. And they're asking us to find what is x. So we know that these are 90 degrees, and you can probably think ahead and think, oh, looks like a Pythagoras question. And it is. There's the triangle right there. So this side is 8, that side is 6. If we know what this side is, we'll know what the full distance is, because if we know what that side is, this side is equal to that side. We just double it, you'll get the answer. So we're gonna have to use Pythagoras. Is 90 degrees because of this property. Line going through a chord means it's 90 degrees. Use Pythagoras using a 6 and 8. Or 8 is the C side, and you do all that, got to subtract, you end up getting square root of 28, which is 5.29. So 5.29 is just that distance there. We're not done yet. We want to know the full distance. Well, that's 5.29. That's 5.29. So just go 2 times 5.29 to get your final answer of 10.58. Okay, another one. And again, all these all these little properties here, they kind of mean the same thing. They're just saying it in different ways. If a line bisects perpendicular, or sorry, if a line bisects and it's perpendicular to the chord, then it must go through the center. So they're just saying the same thing, and all these three things about being perpendicular, bisecting, and going through the center, they're all related to each other. So somewhere along the red line, there will be the center circle dot will be on this red line. And boink, here it is. Okay, so given the following circle, what is the length of the diameter? We want to find out that full length right there. Okay, well, there's the center of the circle, a line there going through the center. There's a chord. It's bisecting it, means that this half is the same as that half. We know the full half is 12, so 12 divided into 2 equal parts means that's 6, and that's 6. Then what you can do after that is you've got a right angle triangle, and we can use Pythagoras. With 8 on that side, 6 on that side, we got to find out the hypotenuse, the C side. And so to do that, again, we know that this is this point at the center of the circle because of this rule here. This line is bisecting that, and it's at 90 degrees, so it has to be the center. Like I said, the base of the triangle is 6 units long. Pythagoras. Now, this is one of those Pythagoras triples, which I'm not going to show you how to do here, but it's one of those ones that you might remember from before. It's the 6, 8, sorry, 6, 8, 10 circle. So x is equal to 10, just using Pythagoras. Oops. Let me catch up. Okay. So it's the center of the circle. Triangle 6 units long, that part there, using the Pythagorean theorem of 8 squared plus 6 squared to give you will give you 100, which is 10 right there. Square root of 100 is 10. And so the radius, or that distance there, is 10. Now that distance being 10, you should realize, I did it again, you should realize, sorry, with this distance being 10, that's also a radius. And a radius is half of a diameter. So that's a radius. Here's another radius right there. So if that's 10, the other half is another 10. So the answer is that full line is going to be 20. The radius is 10, and the diameter has to be 20. Okay, now, cute little thing here about what carpenters figure out where the center of a circle is. So here's a circle, and when they can figure out the exact center of a circle without using any real fancy measurements and stuff, all they do is they draw 2 chords. So they draw 2 chords, one there, any spot. It can be anywhere. It can be there, anywhere. And what they do is they draw a perpendicular bisector of each chord. What that means is they're going to draw a line that is at 90 degrees perpendicular to that chord and perpendicular to that chord. So a line there, perpendicular 90 degrees to that chord, and a line there. Those 2 lines are perpendicular, which means that they bisect the chord, and the point where those 2 lines intersect is the center of the circle. That's a little carpenter's trick there. And boink, that's the center of the circle. Like it says there. Okay, let's take a look at this. Find the missing side x. Let me get to the problem here. So there's a full diameter. There's a line that's going through the center of the circle. It's slicing through a chord, and again, when it goes through the center, and what happens is it bisects this chord in half, and also we know that that's going to be perpendicular to that 90 degree it's going to be 90 degrees. We're also told that that's 10, and that's the missing side x, and that's 6. So based on that, can we find out what x is? Well, we know, like I told you, that this is perpendicular, and so is that. We know that side is 6, the other side must be 6. If this is 10, that's a radius 10. This is also 10. Now people think, oh, then that means this is 10 as well. No, that's not a radius. It doesn't go all the way to the end of the circle. It just goes to there. So that's not 10. But it's no big deal. We can figure it out. This is a right angle triangle. We're going to use Pythagoras to figure out what x is. And so put it all together. Again, all radii in a circle are equal. The chord is bisected, so both sides are equal. 6, 6. Again, because the chord is going through, it's bisecting at 90 degrees. So it looks like that spelling mistake there. And so in that green triangle there, we use Pythagoras solving for the missing side. And we have to use some subtraction. Square root of 64 is 8. So the missing side, x, is 8. It's another one of those Pythagorean triples. Okay, one more. Find the missing side x. Let's fill in what we know. That's 8. That's x. That's 10. Okay, so from that, trying to figure out what this x is, this looks a little trickier. Again, there's a line coming from the center of the circle, bisecting this chord. Bisecting means this line and that line are equal. If that's all 10, and this is cut into 2 equal parts, then that must be 5. And that's 5. If that's a radius of 8, that's a radius of 8. What you can do is draw another radius of 8 by going like this. That's another radius of 8. And then what we've done is created another right angle triangle. So there's the hypotenuse 8, there's the side 5. We just figure this side using Pythagoras. Let's just see how they do it. So again, since the line going through the center is perpendicular to the chord, it must bisect it, which means it cut it in half directly. So they're both 5s, 5, 5, just like I had before. And then again, all the radii are equal, so that's 8. Add another radius to create a right angle triangle like I did. Oh, look at that, just exactly where I drew it. And it's an 8, and use Pythagoras to figure it out, set up this way, where the 8 is the C side. And you just do some subtraction. Square root of 39 is 6.245. And that is that. Not quite. Here's your skill testing question. So for this one, if O is the center of the circle, and OF is 18, OF is 18, GJ is 14, G to J is 14, you tell me what is the length of X and Y. So what is X, what is Y? Give me the lengths. That's it. Hope you found that not too bad. Talk to you later. Bye-bye. Bye-bye.